Welcome back to the School of Muscle podcast. Today, Dr. Archer joins me, and Dr. Archer isn't going to have video for this podcast, so you're just going to have to deal with, looking at my beautiful face, but, you don't get to win them all. So today we're going to discuss a paper that Dr. Archer authored titled, Body and Fat Mass Are Not Regulated, Controlled, or Defended: An Introduction to the Invisible Hand and Competition Models of Metabolism. So that's what we're going to dive in today. So Dr. Archer, could we maybe just start with what kind of led you to wanting to write this article in the first place?
Sure. Well, allow me to begin by saying thank you for having me on. And the main reason was that the current frameworks for understanding and studying obesity, nutrition, gains in body mass, loss of body fat, increase in lean body mass, the current paradigms were just inadequate to explain the phenomena that we see, to explain all the data. So I was searching for a theory of everything. So I was interested in explaining not just the etiology of obesity and cardiometabolic diseases such as type 2 diabetes, but I was also looking to understand their comorbidity. Why do some people have both obesity and diabetes and one without the other, as well as individuals who are perfectly metabolically healthy and yet eat large quantities of fat and sugar and never have any problems with their cardiometabolism. But I was also interested in explaining stunting. Why are some children born small for gestational age? Meaning that they're born smaller and they're smaller throughout their entire life, and they have a higher increase of cardiometabolic diseases. And then I was also looking at the changes in adiposity that occur with age. Why at 20 are people lean and healthy, and then suddenly at 60, they're not metabolically healthy and they've lost their muscle mass. They suffer from sarcopenia and a loss of function. So there are frail, obese individuals later in life. And I was also interested in so-called muscle memory because I was a competitive natural bodybuilder a long time ago. And I stopped training for about 10 years. And when I started training again, my muscles immediately responded. They came right back. And I thought, wow, this is kind of interesting because it took me years and years and years to develop it. But then when I come back to it, it comes back almost immediately. And I thought that there was a relation between that and fat mass. Why do individuals who diet for 6 months to lose 20 pounds can gain it back in 1 week on vacation? So that was the background for this paper.
And I think that hits on a lot of points that are particularly interesting to my audience. And my audience is mostly focused on physique development, bodybuilding, and stuff like that. Stuff that it sounds like you do have like practical experience with as well. So kind of in the evidence-based fitness community, it seems like there's this idea of kind of a settling point to where there's kind of this weight range that your body likes to be at. And, if you go too low, then your body's going to kind of want to increase body weight. And there are some compensatory mechanisms where if you start gaining body weight, then some people defend against that a little bit more than others. But it sounds like with this paper, you're not really a fan of kind of this settling point model. And from your intro there, it sounds like, maybe part of the reason for that is because it doesn't encompass some of these other things that you're kind of noticing within other literature as well. So could you maybe elaborate a bit more on why maybe this settling point model isn't a good idea? And then we can kind of get into maybe some better ways to think about it.
Well, there's an awful lot there to unpack. I think the first thing is, from a scientific standpoint, you have to be a realist. You have to be looking at mechanistic explanations for things and not look at just simple abstractions. So the idea of a set point or a settling point, it's an abstraction. So if an individual weighs 200 pounds and they lose 20 pounds, and then over time their body returns to 200 pounds, that doesn't mean that there's a settling point there, because literally you can't point to a settling point. It doesn't exist in the real world. It's not something that we can put into a model, unless just strictly a mathematical model that's an abstraction. So what I was looking for was strictly a mechanistic viewpoint, meaning how can we describe that transition from losing weight to gaining weight? Why is it easy to gain muscle mass the second time once you've already had it? Why is it easy to gain fat mass once you've already had it? So I think these abstractions, the idea of adipostats and glucostats, and that there's some kind of gravastat, sometimes there's a way of forcing your body to return to its weight, that I think that just from a scientific standpoint, it just doesn't hold water. And I think more importantly, it doesn't explain our reality, because there are individuals who are lean as children and as teenagers, and then suddenly when they're 50, they're morbidly obese. And you have to be able to explain that, because if there's a set point or a settling point for that, how do we get an obesity epidemic that occurred in such a short period of time across almost every population which it's measured. So I think the easiest way to understand this is to look at something that people don't think that there's a set point for, such as height. So allow me to begin with a really simple question. And I'm expecting a specific answer. So I assume you won't get it right because I'm asking a simple question with a very specific answer. But
well, now if I miss it, I'm going to feel terrible for the rest of this podcast.
Because the thing is, I'm assuming most people will get this wrong because it's such a simple answer. So, and I'll give you a hint. So the question is, why are some people taller than others?
My initial response, which maybe is incorrect based on your setup there, is largely genetic related, meaning, if they had tall parents, that they're more likely to inherit some sort of genetic phenotype leading them to be a taller individual.
Okay, so I think most people would probably fall in line with that. But there's a problem, a couple of things. Now, one, there's a tangent that I won't take, which is the conflation of inherited with genetics. Because you inherit many things from your parents. You inherit your cells. I mean, the cell that your entire body developed from was formed in your grandmother's uterus when your mother was a developing fetus, because all the eggs she has were formed before she was born. So the whole idea of inheritance is different than genetics. But that tangent aside, if you were looking at someone and you were saying, okay, well, there's a tall person and there's a short person, can you look at them and see the difference in their genes or their inheritance? Of course not. But what can you tell by just looking at someone if they're bigger? What do they have? And I'll give you the hint. Now, this is the hint. If we were looking at something such as a physical structure, such as a building, because ultimately physiology is physics plus biology, right? So if we're looking at something physical like a building, why is a building taller or bigger than some other building? Let's say it's a brick building. Why would this building be taller or larger?
It has more bricks.
Exactly. So it's a really simple answer. So let's go back to my question. Why is one person taller than another?
Well, I know it's not that they have more bricks, but just their literal bone structure is larger.
Right, exactly. But more importantly, let's drive down. So if you say, what's the building blocks of a building? Well, the bricks. What's a building block of humans? What's a building block of your body? Cells. Right? So an individual who's larger literally has either more or larger cells. So what I have is a cell-centric perspective rather than a gene-centric perspective or a diet-centric perspective. I'm literally looking at the number of cells that individuals have, because this is a realist perspective. I'm not going to talk about set points and glucostats. I'm going to talk about the number of cells you have and how they impact not just how many calories you consume, but the partitioning of those calories to muscle mass or fat mass. And this is how physical activity and exercise, different types of physical activity and exercise, impact your body composition. So I go back all the way to the beginning of the intrauterine environment, the environment that created your body and the number of cells that were produced. So an individual who's taller or larger has either more cells or larger cells. And the only two cells in our body that really change size dramatically are our skeletal muscle and adipocytes, or adipocytes if you're in a different world. So fat cells. So fat cells and muscle cells, those are the two major cells that I pay attention to because they have the greatest impact on the nutrient partitioning, which is when you eat food, where does it go?
Absolutely. And I think this sounds like it's hitting on the idea in your paper in which you discuss the kind of competition model for metabolism, in which there's this relationship between competitiveness between cell size as well as someone's amount of body fat regain or their muscle regain and different things like that. So am I correct in saying that this is what you're kind of alluding to, that competition model of metabolism?
Yes, definitely. I mean, and don't feel bad because I can see that you're kind of hedging on your questions and things like that, because it's a fairly controversial theory, but it's also something new. And it's a new paradigm. It's a new way of looking at things. And anyone who has the old method of looking at things, the old manner or perspective or paradigm, isn't necessarily wrong. It's just that we're speaking different languages. So it's difficult for anyone, especially someone like yourself who's well educated in the old paradigm, to immediately jump into this new paradigm. So the idea behind, the relative stability of body mass. I mean, when people talk about set points, they're usually talking about how, your body should be 200 pounds, so you're going to stay around 200 pounds or 150, whatever it may be. But the only evidence that we have for set points is that stability. And my argument is that stability is not caused by a set point, which is an abstraction. It's literally caused by the number of cells. So if you're born with a greater number of fat cells, you will have an enhanced ability to store calories as fat. If you're born with more muscle cells and you're physically active, because the only way a muscle cell really absorbs lots of energy is from being physically active by contraction. So when you contract a muscle cell, it absorbs more glucose and fatty acids from your bloodstream. It's called disposal. So it disposes of more glucose and fatty acids. So the partitioning of your body is based largely on how many fat cells you have, how many muscle cells you have, and the metabolic activity of your muscle cells. And that metabolic activity is determined by exercise.
And am I correct that for the most part, the number of cells, either muscle or fat cells, stays relatively constant throughout someone's life? I believe maybe fat cells can increase maybe during adolescence. It's been a while since I've looked at this literature, but does it remain mostly stable when it comes to the number of cells?
That's a great question, and it's an incredibly contentious area of research. What most of the research suggests is that early on in the intrauterine environment, obviously you're creating X number of cells. So your body, you're born with X number of cells. And then as you transition through puberty, you're going to gain more and more cells because you literally get bigger and taller. So you're gaining bone cells, muscle cells, fat cells. And it's interesting that there's a sexual dimorphism there, that women will gain more fat cells, where men will gain more bone and muscle cells. And that's why men actually become leaner during puberty, whereas women become actually more heavy. They become fatter. And if they delay that caloric increase that's necessary to gain that fat mass, they'll delay puberty. So there are women who are, endurance runners, things like that. They'll literally delay their puberty because they're actually keeping their fat mass from expanding enough to allow puberty to happen. So the idea is you are born with an initial number of cells, and those cells can increase based on puberty in the number one critical period. And then anytime you're gaining large quantities of fat mass very quickly, you will also increase the number of fat cells. So they are quote unquote relatively stable, but some depots are more labile. They're able to be changed more easily. So if you gain lots of fat mass really quickly, you will actually increase the number of fat cells. And my work shows that if you have more fat cells, then after each meal, those fat cells will take more calories out of the bloodstream. And because they're taking more calories out of the bloodstream, your brain, your heart, your liver, and your kidneys get less calories. Well, what happens? Well, your brain, your heart, your liver, kidneys still needs more calories, so you'll eat more. So if you have more fat cells, you'll store more of the calories that you're consuming as fat, and then that will cause you to eat more. So we have this kind of a chicken and egg scenario where more fat cells drive more energy intake. That energy intake then goes more to fat cells, and you have this downward spiral and upward spiral, depending on your view of it. But the same thing can happen also with muscle tissue. So when you go out and you train, whether you're an endurance athlete or a strength athlete, by lifting weights or running, you're literally contracting those muscles, and you're having those muscles take up more calories. And when they take up more calories, well, your brain, your heart, your liver, and your kidneys still need calories. And that's why lifting weights and running will change your body composition, but it really won't change your body weight, because under ad libitum context, meaning you can eat whenever you like, you're going to eat more food because you're training. And that allows you to get bigger. So you're storing either the calories in your fat cells because you're sedentary and you're not exercising, or you're storing it in your muscle tissues, and your muscle tissues are getting bigger. So you're storing that glycogen and those fatty acids in the muscle. So how you spend your day and the number of cells you have and the metabolic activity of those cells determine not just how many calories you consume, but also where those calories go. And the flip side of this is if you have a large number of fat cells, when you diet down, you've just shrank the size of the fat cell. You diminish the size of the fat cell. And smaller fat cells are more sensitive to insulin, which means when you eat a mixed meal, proteins, fats, and carbs, your blood sugar goes up, your insulin levels go up. And if you have a bunch of fat cells that are really, really insulin sensitive, they'll take up all those calories. Well, guess what? Your brain, your heart, your liver, and your kidneys still need calories, so you'll eat more. So the only way to maintain a lower body fat mass is to maintain a lower caloric consumption than you would naturally do, which means you're going to be hungry all the time, which a lot of people do. People who want to maintain a body mass lower than what you'd say your set point would be, or lower than what I would say your predisposition is, you have to literally be hungry all the time and training excessively, if that makes sense.
Yes, absolutely makes sense. And just spurred a bunch of different questions, but I think where I'll go with this is, so one kind of important key that you mentioned there was when you shrink your fat cells, it can basically lead you to be more hungry, and this is where we see maybe some of those, I don't know if pressures is the right word, but some of those pressures to return back to a previous body weight. And this might be one of the reasons, like you mentioned, is why we kind of coined this settling point or set point theory, to where if you lose too much body fat, you're going to want to kind of return a little bit. But I actually really like your mental model of thinking about it to where it's not necessarily like some abstract settling point that nobody actually talks about mechanisms of why it's happening. It's happening because you have this cell competition to where you actually see this reduction in fat cell size, making you more kind of, I believe leptin also increases when you have shrunken down fat cells, but you have different things that occur leading you to want to eat more food and kind of regain some body fat. Does it sound like I'm kind of understanding that correctly?
Perfect. Yeah, that's exactly, that's kind of a very succinct way of saying what I just said for the past half an hour. So yes, so you just summed it up. It's that literally when the fat cell takes a calorie, everything else still needs a calorie. So the rest of your body is kind of pushed towards eating more when you have more fat cells. And that's where we lead into the idea behind the obesity subtyping. And I have a couple of papers on this where there's a difference between inherited obesity and acquired obesity. So inherited obesity is literally you're born with more fat cells. And so when you have a metabolically compromised mother who has a neonate, a newly born child, that child will have more fat cells. And every meal, more of the calories will go to their fat cells, which means they'll be larger and they'll have more fat mass. And what happens is if you're larger, you move less. So if you're larger and you move less, you're not contracting those muscles. So this is to me the cause of the obesity epidemic, at least the childhood obesity epidemic, is that we're creating children in utero during the prenatal period who are literally designed by their mother's metabolism to eat more and move less. And what's happened over the past 50 years is we have people who eat more and move less. And it's not the food, it's not the caloric part, it's a caloric partition, but not the food per se, because how much we eat is determined by how many calories our heart, our liver, our brain, our skeletal muscle need to survive. And if some of those calories go to the muscle, great, your muscles get bigger, but you still need to eat more, which explains why, exercise by itself doesn't lead to weight loss. It leads to changes in your body composition. Whereas diet will certainly diminish the size of the fat cells, but it doesn't diminish the number, which means you are not changing your metabolism at all. You're metabolically set up to eat X number of calories to fill those fat cells and then supply your heart, your liver, your kidneys, your brain with the calories they need. So yes, you're right.
Yeah. And I think this is awesome because I know, like, just anecdotally with coaching clients and stuff, I have seen a ton of this, like in real world examples where I've had clients that, they've maybe lost a significant amount of weight, and maybe those clients were also clients that have kind of struggled with weight their whole life. And now when they attempt to maintain this kind of lost fat or a significant amount, they notice that they're just always have a very large appetite, and they're always like using large amounts of food volume and stuff like that to try to curb it. But it sounds like with that reduced fat cell size, they're always going to kind of be in this state of being more hungry and wanting to consume more calories there. So one question related to kind of like a mother in this situation is like, are there things that someone can do in those pregnancy stages to, prevent some of this from occurring? Or what would you kind of recommend for someone like in that situation to where they're pregnant, they're going to have a kid? Is there anything that they can kind of proactively do to maybe help set their kid up for success when it comes to kind of this cellular competition model?
Well, I think I love the way you phrase that too, setting your children up for success based on the competition model. I think that's a brilliant way of putting it. I think that mothers who are physically active prior to conception will hopefully maintain that physical activity during the prenatal period. And that is really all they need to focus on, because the number of calories they're consuming will be based on the number of cells they have in their body and the metabolic activity of those cells. So if she's physically active, she'll partition more of the energy to her muscles, and that fetus will demand as many calories as it needs, What happens, though, is if a mother's very sedentary, she's going to become more insulin resistant because physical activity and exercise increases the insulin sensitivity of the skeletal muscles. So your skeletal muscles can take up more glucose and more fatty acids because they're active. And it also increases the non-insulin mediated glucose disposal. So if you're a physically active mom or pregnant woman, you are taking in large quantities of glucose, large quantities of fatty acid, and you're partitioning it to your muscles, and the fetus will take what it needs. Because from an evolutionary standpoint, humans evolved with massive amounts of physical activity. I mean, fight, flight, running from predators, finding food, finding mates. We had tremendous amounts of physical activity, and we've engineered that out of our daily lives. So what we need to do is put that physical activity back in so there's the competition between mother and fetus, because you want there to be a healthy competition. You want the mother's muscle cells to compete with the fetus, but not out-compete the fetus. And you'll see that in communities that undergo subsistence farming, these individuals who are planting small amounts of food, and the mom barely can take enough calories to support herself, and she cannot support her pregnancy. And this leads to stunting, which is what I mentioned earlier. So what I was looking for was a theory of everything. How can I explain everything in the body from pregnancy to stunting to obesity? And there's no theory out there that can explain both stunting, small for gestational age infants, and obesity, childhood obesity. And that's what I've tried to do. I'm sorry. So I'm not sure if I think I took a tangent and I didn't get back to the question that you're asking.
No, you totally answered it. So for a mother in going through pregnancy, remaining active and continuing to exercise sounds like what she can do to kind of set her child up for success there. So maybe kind of before we get to I definitely want to cover practically what does someone do about this information. But before we get to that, maybe let's cover the kind of muscle detraining aspect of it, as, when thinking about this kind of model here. So when a muscle hypertrophies, for the most part, my understanding is that it just increases in cell size, not cell number. So for this individual, if they then go through a detraining period and their muscle cell size atrophies, it shrinks, are they seeing a very kind of similar process that we see with fat cells, to where it's once they start training again and they start consuming enough calories, they regain that muscle quicker for similar reasons to why someone might regain body fat quicker? Or how is it kind of working on the muscle end of things?
Well, I think you've tapped on a really interesting idea, because the idea of fat memory and muscle memory, I think that's a little bit of a misnomer, even though it's a very convenient way of putting it, that our body returns to what it used to be. But that also plays into the idea of the set points, and I like to avoid that as much as possible. But muscle cells are really cool because they're multinucleated, which means they have multiple nuclei, as opposed to most cells in the body have a single nucleus. So when you're increasing muscle size, muscles are mostly water. So the fastest way to increase that muscle size is to increase the amount of glycogen in that's stored sugar. So the glycogen is increased. That each molecule, each gram of glycogen includes about 3 grams of water. So you'll gain a tremendous amount of weight, but it's mostly water weight in your muscles. That's wonderful. So when you stop training, what happens is those glycogen stores diminish, the water is diminished, the muscle size is diminished, but those increased nuclei that you get from strength training, and especially when you have some damage to training, so that's where eccentric training comes in. You get any type of overload is going to create a certain amount of damage. That damage leads to growth, and that growth often will lead to an increase in the number of nuclei within each muscle cell. So that's the idea of nucleodomain theory, meaning that each nucleus in the muscle cell can only control a certain area, so that if the muscle gets bigger and bigger and bigger, you need to form another nucleus. So you'll take these progenitor cells will come into the muscle and actually increase the muscle size. So you're increasing your protein synthesis, you're increasing your glycogen synthesis. So in many ways, the detraining effect is like the person who's lost the fat cell mass. So they'll lose the size. The hypertrophy is diminished both in the fat cell and the muscle cell. And as soon as the conditions are primed to come back, and the only way that happens with the muscle cells is if you're training, whereas a fat cell, all you have to do is have positive energy balance. Anytime you eat a meal, that fat cell will absorb more of it. And you had said this earlier, where there's this impetus to eat more. Your clients are struggling, because they've lost weight and they're hungry all the time. And one of the things I say about childhood obesity, if you were obese as a child and you've transitioned through puberty and you're still obese, chances are you will be obese for the rest of your life. Now you can alter that and you can improve your cardiometabolic functioning, you can become more healthy. So the best thing you can hope for if you've been obese through puberty is fat but fit. So the fit fat paradigm is the best you can hope for, but you can be healthy. And there are some individuals who are, have large levels of adiposity and still look great. I mean, so there are different ways. I mean, you've seen there's some football players who they're incredibly obese. They have large amounts of fat mass, but they also have lots of muscle mass, and they move well, and they're healthy, and their heart, cardiometabolic health is good. That's not true of all football players by sure. But so I think that, moms being healthy and physically active are important, but understanding that from a personal training standpoint, some of your clients will never be a bikini model. They just never will. They're not born. They weren't born that way. They're never going to. So unfortunately, luck plays into this. There's a certain amount of, you're born a certain way. Biology sometimes is destiny, but it's not the ultimate destiny. So your appearance is going to be determined by a large extent from inherited factors. You can change your body composition. Now with men are a little lucky because as they transition through puberty, that boost of testosterone has a huge impact on nutrient partitioning. So you may be, the roly-poly little kid, and you hit puberty, and suddenly, boom, you're this big, strong, massive guy, and you never look back. But the interesting part, especially with the kind of the intergenerational transmission of obesity, is larger body size. So we're seeing a giant increase in the NFL football players. We're seeing a giant increase in these bodybuilders, a giant increase in the size of human beings. And what happens when they stop playing competitive sports? You see this in the Heisman Trophy winners 20, 30 years down the road. In college, there are these amazing physical specimens, and 20 years later, they're morbidly obese with diabetes. So what happened there? What happened there was they're not physically active all the time. They're not using the performance-enhancing drugs that change that partitioning, because that's one of the things you see in competitive bodybuilding, in the pros and things like that. They take so many drugs that alter the nutrient partitioning. One of the models that I was arguing against was the carbohydrate insulin model of obesity, saying that, if you eat carbs, you get fat because it raises your insulin level. Yet bodybuilders are injecting insulin to increase their muscle mass and lower their body fat. So how can insulin by itself be causing obesity? It's not. It's a silly model, and it's been pushed, and there's lots of New York Times bestsellers, but it's not the main. He understands. Dr. David Ludwig is the main person behind this, and he understands a lot of this, but he starts in the middle. And he ignores what causes the insulin sensitivity, which is your physical activity. So, sorry, I took another tangent.
No, that was perfect, because it was one question that I wanted to kind of end with and kind of summarize with is, if someone finds themselves in a state of, maybe they were overweight as a kid for, whatever reason, and they've always kind of struggled with their weight, what can this person kind of do about it? And, there you kind of hit on, if you've been overweight as a child and through adolescence, you're probably never going to be like a bikini model or someone that you might see on social media, and you might have to accept a little bit that you're probably only going to feel your best at a little bit higher body fat levels, but that doesn't necessarily mean you're doomed to just like not have a decently looking physique, because you can put on muscle mass and kind of change how you look. And I really like your examples of football players. That's an example that I've used before, is like, maybe you feel better at higher body fat percentages, but if you take a look at very muscular, like a linebacker or a defensive end, like these guys are not at low body fat percentages. Like I would say 15, 20% for a lot of them, but because they have so much muscle, it still looks good. So kind of with that, is there any other advice or anything else that someone can do if they are finding themselves in that state to where they've kind of always been overweight and they've always struggled with their weight? Like what should this person do? Yep. And, one question that popped into my head earlier is, this kind of cell competition model reminds me a little bit of where people kind of yo-yo diet, to where they go on this drastic fat loss phase and then they regain body fat really quickly after that. And they kind of crash diet again, regain body fat really quickly. And to me, it sounds like this could potentially be a recipe for disaster if they're adding additional fat cells every time they're regaining that body fat. And a lot of these people will report like they have a harder and harder time dieting after every cycle of this, which to me suggests that potentially this is exactly what could be kind of going on with them. But yeah, I definitely agree with your overall takeaways there. For me personally, I was like that roly-poly kid, and even to this day, if I try to stay too lean and I start comparing myself to others on social media and stuff like that, I feel my worst when I'm at my leanest. So I think that now that I've been training for a while and I've built some sort of muscle mass, I can be okay at those higher body fat levels without feeling the need to kind of go down to those leaner states. So I think for me, one of the ultimate take homes here is if you did find yourself in that position to where you're overweight through adolescence and, even into adulthood, that one of the best things that you can do is continue to be active, build as much muscle as you can. And I still think that most people can still get to a pretty good spot there.
Oh, I think that's brilliant. I think it's always nice for me as a kind of an academician, as a research scientist, to talk to people who actually have, their feet on the ground, and you're working with clients, you're working that practical understanding, because you see it every day. And what you just expressed about the idea of yo-yo dieting is exactly true. So I think so many times people think that they need to read the research journal articles, when in reality, if you just look at the world, look at the way it's functioning, and say, wow, there are people who've eaten tons of sugar and fat their entire lives and they're still lean. So it's not the sugar fat. It has to be with what their body is doing with it. So I think the wisdom that you just expressed, I think is important. And I think it's important to understand that. And I think you're right that stay away from the idea that you can, if you want to diet down for your wedding and then forget about it, because chances are that massive increase in body fat afterwards will increase the number of fat cells and make it harder for you the next time. And each time you do that massive diet, it will make it more and more difficult to the point where you just give up. And sometimes when they give up, these individuals stop training. And ultimately, what you just said was the most important thing. I mean, by increasing your lean body mass, you're able to have less relative fat mass on your body. And if you have less relative fat mass, you look better. Right? So it's not necessarily the absolute amount per se, it's the relative. And you were talking about that with the football players. I think that's dead on, 100% accurate.
Yep. And I think this is particularly relevant to competitive bodybuilders that diet off, some people get into a bodybuilding competition because they are already overweight, and then they try to diet all the way into a competition and lose, 40, 50 pounds of weight. It is so important for that individual to have a plan coming out of that, to not just, totally be like, okay, I reached my goal, now I can do what I want. Well, your physiology is going to be telling you to eat all the food and regain all that weight back as fast as you can, which, as we talked about today, is definitely not a good approach for things. So I think with that, is there any other final practical takeaways or anything else that you wanted to mention before we wrap up here?
Well, I think to kind of just to sum it up, I think that how many calories you consume is determined by literally the number and the metabolic activity of the cells in your body. And I think so where those calories go. So not only how many calories you eat, but where those calories go. So being physically active is important. Understanding kind of where you are in the world, understanding that, increased muscle mass makes you healthier, because increased active muscle mass increases your insulin sensitivity. That means it's going to decrease your risk for type 2 diabetes. It's going to decrease all of the cardiometabolic pathologies. So I think that, in closing, I would just say, moms, be physically active before you get pregnant, during your pregnancy, and afterwards, because then you set a good example for your children to be physically active. I think individuals who are on the heavier side should understand that you may not be able to change that, but by increasing your muscle mass, you decrease your relative body fat and you will look better. So that's the best. And I think for everyone else, the guys who are out there that, were born with lots of muscle mass and they're using performance enhancing drugs, because that changes the nutrient partitioning dramatically to a way that guys, natural bodybuilders like myself, you can't compete. You just literally can't compete. They just can get too big, too fast, and they just partition all of those calories. And like you were saying about the guys who, lose 30 or 40 pounds to compete, they have to be really careful if they go off of those drugs, what's going to happen, because the partitioning has changed dramatically, and now they're in positive energy balance and they're gaining that fat mass, and that next contest is going to be a little tougher for them to get back down to body weight.
Absolutely. Well, I think that's a great summary here. If people want to stay up to date on the research that you are doing, and you mentioned that this is kind of a newer kind of concept in this literature. If they want to stay up to date with everything you're doing, is there a good place that they can kind of go to stay up to date with that?
Well, actually, listening to you, I think the points that you made, you seem like you understood the paper. A lot of my academic colleagues don't understand the paper, and they're studying this every day. So I think that having that that broad understanding and having that practical understanding is really important. You don't have to be a PhD level scientist. In fact, being a PhD level scientist makes it harder for you to be there with your feet on the ground and seeing how clients are changing their bodies. And I think it was my practical experience, because I didn't get my PhD until I was 50, so I had all of this practical experience that allowed me to see things that most academics don't see. So I think if you read my papers are dense. They're not easily understood. The paper that you brought up today, it's a really difficult paper to get through, but the thing is you understood it, which is great. But a lot of people don't. And so I think that reading the journal articles really won't necessarily help the average person, unless you're willing to put lots of time and effort in. And I think I would put more time and effort into the gym and less time and effort into reading the journal articles and being more physically active during the day. Rather than spend half an hour reading a journal article, or mine 2 or 3 hours reading it, go out for a walk.
Yeah.
You go to the gym.
Yeah. While you're listening to my podcast, you could go do those things. And
Exactly.
And I totally agree. So my background, I do have a master's degree in exercise science. So I do have some formal academic training in which I've had to, read papers and go through all that. So even for me, it was a difficult paper to read and understand. So I definitely see where you're coming from with, it is a dense paper. It's not necessarily the most simplest thing to read, but I think, it is still readable. But like you said, for the average person out there, stay up to date with podcasts, and then not, there's definitely an opportunity cost to sit down and spend an hour reading a paper versus doing an hour of exercise. So I think that is great advice there. So thank you so much for joining me today. I know I learned a ton, and I'm sure my audience did as well.
That was my pleasure. And thank you very much for having me, and best of luck to you and your clients, because it sounds like you have a general grasp of all the things you need, because ultimately, we have to be a mile wide. You have to look at the whole system. And I think that sounds like you really understand both the whole system and drilling down a little bit. And I think that's important, for your listeners and for your clients.
Awesome. Thank you. I appreciate that.
My pleasure.